Good afternoon, everyone. I hope you're well, and welcome to this Causeway PDS webinar. Did you know? PDS design tools available to you. So I'm Jenny. I'll be hosting the webinar and looking at any of the questions that will be coming in. We've got Tom Fox, the sales executive, and he'll kick off our presentation today. And we'll also be hearing from Barry Blake, the business unit owner, and Mark Halliday, the customer support. We will be running a couple of polls throughout the session. So I'm just going to kick one of those off so we can make sure everyone's comfortable with using those. There we go, the first poll. What projects do you mainly work on? We've got residential, industrial, public sector, or highways. If you just click one of those options and submit, and I can watch them all come flooding in. And then I can share those results with you. So wow, there we have it. 81% of you are working mainly on residential projects. Okay, so with that, I will pass you over to Tom to start his presentation. Tom.
Great, many thanks, Jenny. Lovely. So yeah, we're going to be going through our software today, and many thanks for joining this software. As Jenny said, my name's Tom Fox. I'll be designing and demonstrating the hydraulic design phase of the webinar. Before that, Mark will be giving an overview of the PDS development, with Barry Blake demonstrating the BIM export and the drive module. From looking at the attendance list, we can see that a number of you already have the enterprise bundles. So we wanted to share with you some of the new features that we have developed. And this is really in response to the feedback on the time-consuming aspect of drainage annotation and how to better run vehicle path analysis and how that can be achieved. So we've also going to show you the new module drive that we've developed, which is in line with our sort of joined up thinking approach, as it is intuitive and easy to use. As our software is all developed in-house, we're able to achieve seamless continuity between modules, which we're going to be showing you today. After the demonstration, I will then go on to show where each of the modules sit within the range of bundles, which will be followed by a question and answer session. As Jenny said, we're also going to be running and posting polls throughout the webinar, and this is really to just better understand the projects that you're involved in and the software that you may use. And so I'm going to be handing over to Mark now for running through that.
Right, okay, thanks, Tom. Right, so as Tom suggested, I'm going to go through some of the new things in version 20.11 with you, starting off with the new drainage annotation. So what I've got here is just a PDS drawing with some drainage annotation in it, and this drainage annotation is pretty much as you would have been annotating your drainage in previous versions of the software. So just for a bit of background, as we were sort of going around speaking to various customers over the last few years even, and also receiving feedback on the support line, we found that one of the major pain points you guys were all having was to do with drainage annotation. So PDS was good at producing the information, so you would get the attributes about the pipes and the manholes, but there was still not too much control over the sort of size of text, what information you had as far as manholes were concerned, and so on and so forth. And also there's ended up with quite a lot of work being done in CAD. So a lot of CAD editing, and then of course if you needed to change the design, then you're ending up having to go and do a lot of rework within CAD again. So what we've done for this version of the software is introduced drainage annotation styles, which are a way for you to apply a style which will have hopefully have the pipes and the manholes, the text that's associated with the pipes and the manholes, how you want it to be. We've also introduced some functionality with regards to moving the text as well. So the idea being that the more that you can configure your drainage annotation in PDS to the in-house styles that you want, then the better, because the more you can do in PDS, the less you've got to do in CAD. So in this little part of the webinar, I'm going to just be showing you firstly how to amend a drainage annotation style, and then I'll show you how to create a new annotation style, and then I'll also do a little bit about just how you move the boxes around. So just zooming in on here, what I've got here is really just the annotation style as you would see it now. So this is pretty much based, if you open up a drawing in the new version of the software, this is pretty much based on how the old annotation would be. Okay. So one thing you might notice is that I'm running with some icons that you might not be familiar with. This is just a new icon set that we're testing out currently, so it's just a little bit different from what you're used to. So if I just pop into here, I'm just going to our drainage annotation styles. So when you've loaded up the latest software and you want to do some annotation, then there'll be a default style, which will be based on however your drainage annotation dialog box was set in the software previously. And so what I want to show you is just how do we edit that default style to change the information that you can see on the screen here. So I'm just trying to move my dialog box so you can see the information. So as I say, fairly typical sort of annotation that you've got at the minute. So what I'm going to do is going to pop in, edit style. So I'm going to go in and edit this default style. It's a tab dialog box, so I can amend, edit information about the manhole annotation, the annotation associated with pipes, inverts, and so on and so forth. So what I'm going to do here is I'm just going to pop into text contents. And so for my manholes, currently what I've got is that it's only the manhole number that is shown. But I do have a list of other things that I can show over here. But just for the number, it's currently set to 1 meter. I'm going to make that 0.5. So I've got control over the text height straight away. Anything that's over here that I want, so I want to add the cover level, I just simply drag and drop over there. And I can make that a different height if I want to. So I can have the manhole numbers at 0.5, these at 0.35. I've got the option for putting in a prefix or a suffix. In this case, I just want to put in this cover level, CL for cover level. So go OK. Come out of here. We can also put an outline around the box for the manholes, and I can have a leader line. So I'm going to do that. Quickly pop into pipes. Similar sort of idea into text contents here. I've got something already set up here. So for example, diameter is the first thing that's going to be shown. Again, I can control the text. I can have it whatever height I want it to be. The gradient, change that as well. Prefix, I can change that. So I could just shorten that a little bit. Usually space is of the essence in these things. Pipe type, again, just the height change there. Length of the pipe, so I'll pop that in. Not only can I change the prefix or the suffix, I can also change the precision. So if I don't want the pipe length, there you are, 693 right down to the last millimeter, then I can change that. So I'm just changing the precision down to 2 decimal places. I can go OK on that. There are other settings, but I won't go on into those at the minute. So what I'm going to do is just save those changes. When I do that, you can see that the style or the text has changed to suit my style. Okay, so it's as quick as that. So that's just the default style. I'm just amending that. It could be that you want to have a number of different in-house styles of your own, or it could be that over here, for example, this might be deemed to be sort of non-adoptable. So I could do a different style for the non-adoptable drainage. So what I wanted to do is just show you how you would set up your own style, and then how you apply it to the drainage that's in your drawing. So again, what I'll do is just go back into that configure annotation style. I'm not going to add a new style right from scratch. You can do, just to speed things up, I'll just duplicate the one that's there, which is my current one. And I'm going to call it non-adoptable. Okay. I'm quite happy with the manhole style, so I'll leave that for now. I'm going to go into pipes. I'm going to say text contents. And let's just say I don't want the pipe type. So all I do is, rather than dragging things across into here when I want them, I can also, by the same token, just drag things away that I don't want. And I can say there's my diameter, there's my gradient. I'm happy with that. And I'll go OK. Because I've only got one line of text, I'll just move it up above the pipe a little bit. Sometimes what you have we've seen on drawings that customers have sent us, is that they like to omit the diameter if it's of a specific size. So maybe if it's a 100 diameter pipe, then I don't want that to be displayed on the drawing. So I can omit that. So there's a few little things that you can do in here. And if I save the changes, of course, I've set up the style. but none of these pipes know that they should be using that particular style. And the first thing that we need to do for that is to just add a sewer type in here. So currently the annotation style is linked to the sewer type. I'm going to just create another sewer type, which I'm going to call non-adoptable. And then I am going to select the annotation style that I've just created, which is non-adoptable. The default link type is to do with when we transfer over to our flow software. So I go OK on that. So I've now got my sewer type set up, and all I need to do is tell PDS which pipes and which manholes are going to be using that particular sewer type. And I can do that through Edit Drainage. So I go into here, change the sewer type, and I'm going to say I want to change it to the non-adoptable. There's my two annotation styles. Right, so it's asking me to pick the pipes. I can't be bothered to go around and pick them all individually, so I'm just going to put a window around the ones that I want to change. Okay, and that's it. So you can see then I've got the diameter there, 150, 1 in 155. That pipe there is a 100, so it doesn't show the diameter on it. So that's my different style. If I do want to change them individually, I can do. So if I just pop back into Edit Drainage and say, you know what, those pipes might also be the non-adoptable style. And you can change the style of the pipes at any time. If I get that wrong and I say, oh no, actually those were meant to be back to the sort of adoptable, my default style there, okay, I can do that just by going into Edit Drainage and saying, actually, you know what, default style, I'll just pop them back to how they were. So you can go and change these styles at any time. Again, if I just pop back into that style here and go back into the default one and go Edit, for example, you can change the offset of the text box from the origin of the manhole. So they're a little bit close. Okay, so I'm going to make them 1. Save the changes, come back out, and that is reflected on that particular style there. Okay, so you can change these styles as much as you want or as little as you want. You can use them quite extensively if you want to set up your own in-house styles, or you can just use the default one and change it on the fly. So there is within annotation style, you can copy to and from a global library. So once you've sort of set them up in a drawing, you can push them off up into a global library that everybody uses, and you can all have those styles available in your project as and when you want to use them. So it's quite powerful. I've just one last thing on drainage annotation. Then I've got the boxes here set to my sort of default 1 meter offset, but there are occasions where you might want to move your manhole boxes around. So I'm just going to show you what we've done as far as moving is concerned. So here I've got 2 choices of how the box should react if I subsequently move manholes, and I'll come on to that in a minute, but just bear with me. I'll go with lock relative. So I'm just going to move this box here, which hopefully you can see, and I just move it around. Notice as I did that the leader line changes automatically there. So clever stuff, I suppose. Right, so that's just moving that relative. Okay, and then I'll come back into that dialog box, and then I've got lock absolute. So you're thinking, what the hell is he going on about here? So the difference between the relative and absolute is just how the text box will behave when you move something. So if or move the manhole. So if I move the manhole and go up to here and start moving this one around, then you can see is moving. The box is moving with the manhole. Okay, you can probably see that. Whereas if I come down here and move this particular one, you'll see that the box stays absolutely where it is. Okay, so the difference between absolute and relative. So that is a quick introduction to the annotation. So next thing that we're going to show is the how we apply flow controls and structure information in our hydraulic design package flow, and more importantly how that imports back into PDS, and well, from my point of view more importantly, but how it comes back into PDS and how we can view it on long sections and on plan. So I'm not going to use this particular drawing because it's all designed. You've got all the hydraulic information is already there. So I'm just going to pop into a different drawing. I can find it. There it is. That's the one. So what I've got is just a small layout that I've just put in. Okay, I've got a long section over here, just a drainage section that has the manholes already assigned to it. So just before I do the transfer out and pass it over to Tom, I did just want, I know I said I'd finish with drainage annotation, but I haven't quite, because what we've got here is annotation on something that I've just inserted, some drainage that I've just inserted, because when you insert drainage to start off with in PDS, you get the choice of a sewer type. So you could choose your default sewer type, or your adoptable or your non-adoptable. So you can choose the style of how you want to annotate your drainage right from the start of when you are inserting it. So what I've got here is an annotation style that has the diameter and the gradient, but of course that's not known yet because it hasn't been designed, but you can see that I've got the pipe code. You could have an annotation style that only has the pipe code in, if that's all you want when you're doing the initial layout, and then you could pass it over to your hydraulic design tool, bring it back into PDS, and when you want to do the final drainage, all you've got to do is just change the, just assign the sewer type that has the annotation style that you want for your final drawing production, and that's it, job done. Okay.
Mark, just on that one, we've got a question come through from Matthew. He says, can you change the font too?
Not in PDS. We haven't. PDS is kind of fontless, so it's when it gets exported out to AutoCAD that it then uses whatever the current default font is in AutoCAD. So we normally recommend something like Monospac 824, I think it is, something like that, a monospace font. So PDS itself, standalone, is fontless. If you're in the AutoCAD version, then it will be using whatever the current font is in AutoCAD, or if you're exporting it to AutoCAD. Okay.
Thanks very much.
Right. Okay. So where was I? Transferring the data over to Tom then. So that's the same as it's ever been. I will just export out this file to Flow, and so it will ask me for it. Believe it or not, I did practice this before. You might not believe it, so I've already got the file there. And there we go. So that's sort of over to you. Tom's going to run you through Flow and adding the flow controls, and then he'll pass it back to me to show you how that imports back into PDS.
Okay, lovely. And did you want to run another sort of poll question again?
Absolutely. So this one is actually around the drainage. So do you use any other software in the execution of your projects? So once again, if you select one of the following, and there we have it. I'll share those results. There you have it, Tom.
Great. Yes, very interesting, the results there. Good. Okay, what I'm going to do now is we're going to go through just giving a quick overview of Flow. I don't know if some of you guys already use it, so but just for the other guys, I'll just give you a bit of orientation. So in our design settings, I've put in our return period, we put in our M560 and our ratio R, which we can get from the UK SUDS website, which is a free website. And then we've also put in our minimum backdrop heights and our cover levels. And then what we're able to do is then look at our nodes. So within our nodes, we can see that we've got our range of nodes. Now, what we wanted to do was put in a rectangular manhole in on number 4. So all I've done is I've just typed in the diameter and the width onto there, and we can see a representation of that by going to our by displaying this. So here we can see that now instead of the circular manhole that we had previously, is that it's now moved to a rectangular version. And what we can also do then is if we click on our crossings and clashings, we can see this file network that's crossing. We can now see that a red cross has come up on the screen showing exactly where that file network is. So moving on to our links, we can go to our links. I'll just turn off the plan view. So looking at the links, you can see that we have this sort of this traffic light system, and here we've got an amber, and so this is just letting us know that our maximum velocity has been breached, and so it's just giving us a warning of that. It's not telling us that that's a huge problem, but it just may help us to avoid any scouring or any adverse wear to our network. The next one down is looking at hydrographs. It's very brief. So if we wanted to change our network at all, or the site specifics, so here we can put in design modifiers, put in a time area diagram, or if you're surcharged outfall into a water course, then you can do that, and but then you can also have that on selected times, but that's all user definable. Now, moving on to the flow controls, here we can see that we've got a flow control. We're using the hydroslide because of our site being fairly tight on space. So we used a hydroslide to minimize the amount of excavation required. We can change this. This can be an online. We've put our invert level in and added in our depth design and our flow design flow, and then by clicking on our calculate button, it will then automatically assign a hydroslide for us. Now, as you'll notice, we put this on the outfall, so you are able to put flow controls on the outfall. You don't need any dummy pipes to do that, and then also you can put multiple controls on a single manhole. So here we've got a weir. Now we've used this as an offline control, so we're just showing you can use online and offline control types. And again, you've got your you put in your width and your discharge coefficient, and then you're able to have your second control on your outfall. And then the last control that we've got is our orifice plates that we've got on our car park at the top end of our run. And again, we've used our orifice plate calculator and our calculator button here to do all those calculations for us. So now that we've got our now that we've looked at our our flow controls, you can get all those information for the greenfield runoff calculations from our simulation settings. So if we go to a simulation settings, you can see that you can use the IH124 method, and again we've got our SAR and our soil index and our region. That's all been taken from the UK SUDS website. And here you can, it'll generate your growth curves. And so here you can see that we've got our hydroslide is down to our 2.3, and for 30 years it's 6.6 and 8.7 for the 100 year. So it really is a really low flow site. So once we've determined our and put in our flow controls, we can then look at adding in our storage structures. Now again, if we go from the simulation settings, we've got this great tool, this is a storage estimate tool. So by clicking on there, we can add in our the criteria that we want it to meet. We're going to be doing it for 100 year, 30 plus climate change, and we're going to be having the peak discharge, and that's for that 1 year. So we're going to be adding in for the 100 year, but for the 1 year flow control. Flow rates, and so this will give us a bandwidth. So if it's very free-flowing soil and you're able to infiltrate very well, then and you've got a really efficient flow control, which the hydroslide is, it'll be down near the the 140. Or if it's very clay and a very inefficient flow control, then it'll be up near the the 189 size. So we can say okay to that, and then if we go and click and look into our storage, we go into our storage, we can see that we've put in our infiltration for the base and for our side infiltration, and that would be generated through the BRE 365 drain down test. We've put in our 157.8, which is the middle of that of those levels that we just calculated, and we've put in our up to our side infiltration, and then we've also given it a porosity of 0.95, and that's because we're going to be using a crating system. And then we can then look at adding our storage structure at the top end, which is a car park, and I'll just show you the different structures that you can use. So we've got soakaways, line soakaways, car parks, linked infiltration or linked surrounds. And obviously on this one we're doing a car park. Again, we can put in our infiltration coefficient, and then because we're using washed stone, we'll have a porosity of 33%, so 0.33. We've given it an invert level, and then we've given it a width and a length and a slope. Now, if we wanted to then have a look at the flow control that we're going to be using on that, we can hover over the top of that node, and then we can just click on the orifice, and it will bring us back and navigate us back to the flow control that we're going to be using. So now that we've done our storage, we can then look at generating our results. So if we go to our results page here, you can click on and run those results here. Now, this may be a good time to ask Jenny if there's another poll question to run while that's running.
Absolutely. So the next poll question, you should be pretty good at these by now, is: do you design using multiple controls on a single manhole to control flows for set return periods? Quite a simple one, yes or no. And there we have it, quite closely matched to this one. Back over to you.
So here we can see that we've passed for the 130 and 100 year without any flooding, and so we can also run an approvals test as well, and that will run through a number of different criteria that we can run through, and that's really to generate an executive summary. So now that we've done that, what we're going to do is we're going to hand back to Mark so that he can generate and look at the network being brought back into PDS. So I'll hand it back over to you, Mark.
Thanks, Tom. That's great. Yeah, I've been sitting patiently in this drawing, just waiting. Right, so here we go. So what I'm going to do is import the file from Tom. So I'm going to go into import flow. Okay. And here's the file. So you can see that reading it in. And notice one thing I didn't mention is when we're exporting out and importing, it's only one file. The storm and the foul are all contained within the flow file, so not two separate files. Right, and there we have it. So it's imported the information for me. It's just updating the long section, which you can't see, but we'll have a look in a second. So number one, we can see that the diameter and the gradient and so on, all that information is now back into PDS. The manhole that Tom changed in flow to be a rectangle is in PDS. So I don't know if that might have been something that passed you by, but the latest version of PDS supports square and rectangular manholes. Also, what you will notice is that the flow controls are here. So the flow controls that Tom was demonstrating in PDS, in flow, are here. You can see them. The same convention is used. So that represents that square with the cross through it is an online control. The dotted sort of halo going around the manhole there, that indicates the storage structure. So we're using, again, the same type of convention as in flow. And if I scroll all the way down to the bottom, because I think that was where a lot of action was happening, we've got the, I think it was that an orifice, that one, or a hydroslide?
There's a weir and a hydroslide.
Yeah, so that's the hydroslide flow control there. That's online. The one here to the side is the offline control, and then we've got the storage structure around it. So that's all pulled back into PDS. If I go to the long section, which is updated, you can see there is the online orifice plate. I think that one was with the
car park.
Mark, can you put yourself on mute, maybe? Yeah. Right, and if I go to the end, then also got the same thing. There's the online low-level sort of hydroslide, and there's the offline weir up there, and there's the storage. So all of that information comes through. You can see over here, I've got the rectangular manhole in the schedules. Everything is there, and if I need to take, for any reason, there's a slight design change or whatever, then I can transfer this information back to flow, and all of those controls will be maintained and be seen in flow, and then you can make the amendments that you need and come back, so you've got that sort of full round trip of flow controls and storage. And if you really want to get down to it, then if I go into here and say that I'm going to just report on the drainage, you're all familiar with the report drainage then you can see that I've just ticked the box that says ancillaries, and just to prove it, there they all are. So for example, there is the flow control on node 7, it's a hydroslide, it's got an invert level, blah blah blah, so on and so forth. Everything that Tom has input about that hydroslide, including even the notes and so on, are being passed to PDS and will be passed back. Okay, so that is that bit, and the last thing that I'll be showing you on some of the things that are new in 20.11 is drainage under and around buildings. So this is my last bit, you'll be pleased to know. Right, here we go. So services. Services is a module that we introduced probably about 18 months, 2 years ago. It's was principally used for inputting sort of gas and electricity, that type of thing, those sort of nodes and links. We had some response from customers that they were working on larger building schemes such as hospitals and libraries, that type of thing, that had a requirement for underground building drainage. So we've been doing quite a lot of work on that on the services to accommodate the underbuilding drainage, and we've also thought, well, it might be useful for residential as well. So I thought we'd just put this into the webinar and show you, and hopefully you might find it of interest. So I'm in the services module, and what I'm going to do is just show you how you insert just a series of underbuilding drainage. So it'll be individual pipes and runs, and also I'll show you at the end what happens when you start moving the manholes and pipes that they tie into. Okay, so what I've got here is I'm just going to insert this service run. This is a storm rainwater pipe. As I say, there's a whole list of them in a library. It's a user configurable library that you can add your own services and under and around drainage to. I've got a proposed model, so I'm going to get the cover level from the proposed model, but it can just be, you can prompt you, or you can insert it in explicit cover level as well. So I'm just going to say OK. And so in its absolute basic form, what this command will do for you is, if I just say I want to stick my rainwater pipe there, and I want it to tie into this existing kind of rainwater pipe, or existing in terms that I've already got it there, I can just click on that, and the system will come up and say, do you know what? The current gradient, that service is 1 in 2, which is a bit steep. I want you to change that. It tells me what the cover level is, and it tells me the depth. So in my library, I've specified that it should be 0.6. So effectively, I'm digitizing the rainwater pipe. It's saying that it's going to put it down 0.6 below the PGM level, and then it's telling me what the soffit level is of the node that I'm connecting into, and what do I want the gradient to be. I either approve the gradient or I change it. In this case, I want to make it 1 in 12, and then I get it to recount the upstream level. It tells me that the depth of that is now 1 meter. So to flatten it out, obviously it's got to go deeper. And I go OK, and I could insert another one immediately, but I'm just going to say done, and there it is. I've set up a similar sort of annotation style that follows through into the services, the same annotation styles that we used in PDD earlier, and you can see that I've got the information's already there. So that's just one simple node directly into a connection. We can also do a run of services, so, or run of around building drainage in this case. So I'll just stick with that. I won't actually, I'll change it to be a foul because it is foul. Okay, and what I'll do here is I'm going to go from here down here and tie into that existing PDD foul drainage pipe there. Okay, so I'm going to go from here to there, and then when I digitize onto this pipe, it knows it's a pipe, and it asks me what I want to do. That's the angle that it's going to tie into. Do I want it tying in at that angle? Very close to 80. So if I know that I want to use a nice round number, then I can do that, or I've got a list of specific angles that I can tie into. I can put in a small radius bend in here of 0.25 in this case, and I go OK. Same dialog box, but it's treating the whole run right from, if I can just drag that dialog box out of the way, right from there all the way down to there as one run if I wanted to. So currently the gradient, if it goes down at 0.75, which is the depth of that node there, under the PGM, if it goes down and ties into that main drainage there, then it's going to be going at falling at 1 in 17.029. So it's up to me whether I want to have it doing that or not. And if I say, yep, that's okay, then that's fine. Or if I said, no, I want it to be a bit flatter, I want it to be 1 in 25, recalc the upstream level, and you can see it's reduced the, or increased the depth there. Okay, and if I go okay, is it okay to accept this constant gradient? If I say yes, then that's all going to be going down there. If I say no, it will then take me back through each of these pipes in turn, and I can change the gradients if I wish, but I will leave them like that for now. Okay, and again, if I said done, it would go and annotate the whole thing. So I'll do that, and there you go. You can see the annotations. Right. Okay. One more little example. So here I'm just going to insert the same thing. It's under this building here. I want to go from the end of that and directly into this node here that I've just created. I'm not going to do any recalculation, so that's done. Oops. And then what I wanted to show you really that you can saddle into another connection. So here I'm going to go from here and down to here and go into that connection. At a specified angle, let's just say 50, because that's what the manufacturers state. It's got to be 50 and not 48. They don't manufacture them in 48s. And there we go. And so then again, I can change the gradient if I want to. So it would change the depth below there. So I just make it 25, recount the upstream level, go OK. And so hopefully you can see just underneath there, it's tying in. And I'm going to say that's done then. Okay. And then one final thing I just want to show you is this. Particularly when we're doing underbuilding drainage, people started talking about, oh, well, we've got piled foundations or pile caps. We've got things that we've got to bend our pipes around. Okay, so whilst you could put this in as the bend, the bend point as a node, it wouldn't really be a bend. It's just sort of just would be a sort of a kink, effectively, which you don't really want. And so we have introduced the concept of a bend, which I'll show you in a minute. So that gradient, I'm just going to make it 1 in 25, so it's a nice round number. As we'll see in a minute why I'm doing that. So I'm going to say done. But we've got the option to edit a connection. And would help if I pick the connection. There we go. And in here, you can edit the curvature. So I can add in what we call an IP, an intersection point, but it really is just the sort of bend point, and you can specify the curvature that you want, which I've got 0.5 set up here. And there we go, insert. And so I'm just going to say I want it there. I will do something a bit random here just so you can see it. So I'm just going to go over here and over there just so you can see we've got some bends. Okay, so it looks a little bit crazy, but you get the gist. So now I've got my 0.5 meter sort of radius bends, and you can see that's minus 1 in 28. So I did say I wanted it 1 in 25, but as soon as I introduce the bends, then you can see it flattens it out because it's got a further path to travel. So it is calculating the gradient all the way along those bends. That is a bit too crazy even for me. So I'm going to go back in and say, you know what, I want to edit that, and I want to edit the curvature, and I want to delete that one there and that one there, and go back to that one there. Okay, and there we have it. So we've got the concept of bends, of tying in, saddling into connections, and so on and so forth. And one final last thing that came across as quite important. If you're tying in your services to main drainage that's been designed in the PDD module, what happens if you go and move something in the PDD module? Because it's going to leave all these things, you're going to just leave these things hanging around in space where they're connected. What do we do? So we came up with this as a solution to that, and I'm going to show you. So what I'm going to do here is I'm going to move this foul water manhole, and we'll see what happens to the connection over here. So into move manhole. So I'm going to pick up that manhole, and I will just move it down here somewhere. So you'll see it move. And even though I'm in the PDD module, it's recognized that there was or is a service connection that is attached to it. And so it's kind of just got it there and saying, well, what do you want to do about it? So what I can do is say, well, I'm designing both the main drainage and the private drainage, or whatever it is here, the under and around building drainage. So I want you just to go and reconnect it into here and tell me about it. So the minute I go, that's the manual. And if I go OK, then it prompts me as it was doing before, and I can say, yeah, you know what, that's okay. 1 in 28. It's not made it too flat or anything like that, so I'm good with that. I'll go okay, and then it will tie it in for me, and I've approved it. Okay. There's another choice on there, which I'll show you in a minute, because it may be that, you know what, I'm moving all my drainage around, and I'm importing this from Flow, from my hydraulic design software, and there could be, you know, there could be moves that involve a whole lot of these, and I can't really be, I don't want to do it now. I would like to do it later, or it could also be that somebody else is responsible for the private drainage. I'd rather they did it. Okay, so as I just move this back over here, instead of saying manual, prompt me for each service reconnection, you know, I want it to do something automatically, and you'll see what happens now. So it goes okay. What it does is it kind of reties it in, but I'm not going to approve it in any way. I'm going to leave that for somebody else, or maybe me tomorrow or whatever. So you get this warning triangle comes up. Okay. And so that means that when I next reopen the services, I might have a whole load of these, and I can go back into services the next day or whenever it is. It could be passed to another person, as I say, and you go back into services, and then you can see there's a warning triangle on there. And so you can go back in and say, yep, I just want to have a look at that particular connection there. And then I can decide whether I like the gradient of 1 in 22. If I don't, then I can change it and recalculate it. If I'm happy with it, I can go okay. And as soon as you've been in there, effectively approved it, then the warning triangle is removed. So that's what we've been doing for under and around building drainage. But we thought it might be useful to show it in the context of a sort of residential type development, as it may be something that's of use to you, and then we can sort of further develop depending on what your requirements are. Right, so that's me done. I don't know if you remember that the drainage that I did about 10 minutes ago, with all the flow controls on it that Tom had passed to me. Well, Barry's going to show you how not only can all of that information be passed back to PDS ongoing, it can also be passed out to Navisworks, which is a BIM collaboration tool, and we can view that information there. So over to you, Barry, I think.
While you're going over to Barry and swapping over, I'm just going to run a quick poll on that. So we've got, do the projects that you work on require BIM functionality? Yes or no? Or sometimes?
Or sometimes.
Okay, so I'm going to close that poll and share the results. And there we go. Quite interesting.
Okay, hopefully people can see my screen. So good afternoon, everybody. Right, as Mark said, I'm looking here at the drainage network that Mark did earlier, passed to Tom. Obviously, Tom did some work in Flow, that was brought back to PDS, so we can see exactly the same as Mark was showing. Flow controls in there, obviously the rectangular manhole and so on. And what I'm going to do here, I'm not going to take too long because I think we've actually run quite a lot over on the other things. I'll just show you the principle of this really. Exporting to BIM. It's something we get asked about quite a bit, and basically there's no change to the way that you work in PDS. Carry on as normal, as you've seen here. But then we get to a point where someone says, I want that in Navisworks, I want it in a BIM collaboration environment, and we can export the information. So here, I'm going to create a DWF file. This is specific to our PDS Enterprise system. And you can control how the data goes to BIM. You can control the ground modeling information, the drainage information, the alignments, and so on. Here, I'm going to keep it very much focused around drainage, and we can look at, you know, what do we take out in terms of information, in terms of the pipe work, in terms of things like flow controls. Yeah, so yeah, the type of flow control, the invert levels, the size, and so on, and also if we've got them, storage devices as well. So I'm not going to labor too much on this, but just to create a file and export this out. As we're doing the export, it's attaching all of the attribute data to my model. It's also going to create it all into 3D. So if I just put a window around there. So it'll project the pipes into 3D and the manholes into 3D. And I'll just take my digital model out as well. Okay. Just very quickly then, I've written that information out. Let's just have a look at how that imports into Navisworks. So in here, rather than waiting to go through the whole process, I'd already set something up so that you could see basically we write it out of PDS, it comes through into Navisworks. You can see here the 3D representation, you can see the manholes, you can see the pipe work, you can see the rectangular manhole that we created in Flow and PDS. And down here, I've frozen out the ground surface so that we can see more clearly the drainage network. You can see in here the flow controls in here with the same sort of annotation as we were looking at in Flow and in PDS. We can see the storage device, and we can then start looking at you know, what happens then if we pick on any of this information. So if we look at, say, pipe 1005 in here as an example, over here, what information have we got about that pipe? And it will tell us basically the length, the diameter, pipe type, etc. So all of that information that we had in PDS is read through. Same on the manholes. So if we just pick on a manhole in here, same thing, it will tell you the diameter of manhole, coordinates, and so on, right down to things like the flow controls. So our flow control that Tom put in Flow, our Hydra slide, has been read back into PDS. It's now gone right the way through the process into BIM. So all of the information that we held within Flow, within PDS, is now in our BIM model. So we're completely outside PDS, but we've got all the information. And the same on the storage structures as well. So if I just pick on the storage structure, you can see it highlighting in the model here, and through here, again, all of the information about that particular structure. Okay, so that was as far as I really wanted to go in terms of the BIM workflow. It was really just to show you the information that we were working on earlier being brought right the way through into BIM. I have one more thing that was on my list of things to do, which is a very, very quick look at Drive. And given that we are running short of time, and given that we do want time for Q&A, I'll keep this bit very, very brief. Those of you that have got the upgraded to the subscription professional bundle have already got this package. So effectively, it's something you've already got. Just wanted to give you a quick taster. If I just look in here, we've got the ability to set up things like display styles. So where we're looking at here, a path that I've created, I've basically done some forward movement here, some reverse movement. I've set up the styles that I want to appear. So this is all user controllable in terms of the layers and the color display, whether you want to see the overall envelope or just the wheel tracks and so on. We've got a vehicle library in here, so we can go in and look at the library. We can edit vehicles. We're looking here at the DB32. I could have a look at the FTA. We've set up a number of different ones as standard, but obviously you can customize those. And you've got a wizard interface here. So if you need to set up a different style of vehicle based on one that's already in the library, make a copy, edit, and then use it. My system is a bit sluggish in here at the moment. So let's just very quickly, so I'm going to do one quick path in here just to show a little bit of the software. But as I said, some of you have got this, so you can actually take a look and play around with it yourselves. So we can basically pick the type of vehicle. So is it a DB32? Is it possibly an Arctic? Probably not the right thing to be doing in a demo really, but let's just have a quick look at an articulated vehicle in here. Let's say I'm just going to position it somewhere here, and let's just drive it, orientate it coming down the access road here. And Really, the main thing I wanted to show you here was these predictor curves. Very, very useful when you're trying to maneuver a vehicle. It shows you basically what would happen if you were going direct straight ahead, but you've also got hard left, hard right. So if we just bring this truck down the road here, yeah, and you can see basically I'm going to turn right into this access road down here, and the predictor curve will give me a clue as to whether I can actually achieve that. Yeah, so if I just come a little bit further down here, turning right, I can actually see that that's going to swing right round there. Yeah, and it's predicting for me whether that's going to be possible or not. And then just come off down here and down into here. Yeah, so basically I could see as I was starting to do that path, as I was swinging round, it was telling me that I could just about avoid that curb line in there before I actually committed to that movement. So really quite a useful way of maneuvering vehicles. We've obviously got forward reverse, we've got reversing artics in drive, which is a great thing. I would have thought for anybody using PDS who used the old PDS vehicle path package, that was one of the big downsides really. And obviously we can go back and review this. We can drive the vehicle, so we could say I want to track this vehicle and look at what's happening at a particular point. So I could say in here, pick that path, and I now want to drag that vehicle along the path. Yeah, so you can see exactly what's happening at any particular point. Okay, right, I wasn't going to take it any further than that. I was going to leave it there because, as I said, we spent quite a lot of time on the drainage side of things and the around building drainage as well, which we thought was pretty important really, because a lot of the mods that were done in PDS itself. But just wanted to touch on what we were doing around the BIM workflow, and also just touch on drive, just so that those of you that have got this as part of the Pro package can see what you've got. Okay, I'm going to leave it there and stop my particular demo. So I think really we're at the Q&A slot.
So we've got lots and lots of questions in from the presentation we've done today. I am aware that we're running a little bit over, so I'm going to propose that we run through those questions now. If you do need to head off because you've got other engagements, then we will be sending you a recording so you can catch up with anything you might have missed at the end. But we will start answering those questions. So the first one we've got is from John, who says, this I think was related to your presentation, Mark. Can we display true pipe thicknesses now?
Not at present. So again, we're waiting for customer feedback, and so that's something we could potentially take on board in the future. But,
okay.
But at the minute, no.
This is why these
Sorry, John.
questions are useful. One from Martin. Can you move other text apart from the manhole details?
Yeah, so the manhole details are in a box, and as you notice, I was moving everything, all the text goes at one time. So it's always sort of maintained within that box. We can move the pipe information, so that when I was sort of showing the diameters, gradients, and so on, those four, I think, and pipe length and type. So there were 4 items of text. That is also deemed to be in a box. You can't see the box, but trust me, it's there, and so you can move that text away from its default position if you want to. And again, we'll be looking at things potentially. Maybe people will want to rotate the text or something like that. So we might look at those sort of things depending on the feedback that we get back. But basically, it's currently the manhole text or that cluster of text that is associated with the pipe. So in a way, yes, we can move other things.
Thanks, Mark. A question from Andrew, who says, when will the plan view be rolled out for Flow?
It's already out. It's version 4. So I'll answer that one for Tom, just to save swapping to him.
There you go. Question from Mark. Do you still have the functionality to export to micro drainage?
Oh, yes, we do. Absolutely.
Fantastic. And question from John. Are the M5 to 60 and R not available within the Flow software? Must they be sourced separately?
That's probably one for someone.
Yes, so you would have to source those separately. We don't have a digitized map in like in microdrainage, and that was an active decision because the map it has been hand digitized, and so there can be errors within the M560 ratio R. So we advise people to go to the UK SUDS website and get it from there, and it's a free piece of software, and we're also looking at being able to bring in RefH2 and FH13 as well.
Thanks, Tom. I think another one for you as well from Adam. Can you view the 10-year greenfield runoff in the software, or just 1, 30 and 100 years?
So you can run a simulation for the 10-year. However, you wouldn't be able to generate that as a greenfield runoff calculation, but you would be able to run a simulation against that.
Thank you. From Robert, we have a couple of questions. The flow interface seems quite cluttered with multiple clicks to navigate between items. Is there a proposal to streamline this?
Well, as the software is all in one platform, you're not having to go into one section for doing for sizing up structures. We feel that it is very easy to orientate yourself around it, and but if there are any sort of suggestions of how things could be streamlined, of course, if you get any suggestions of how that could be done, we'd obviously look at it.
Thank you, Tom. And he also asks, can you add annotation for flow controls in PDS?
Okay, that's back to me. Again, not currently. I mean, as you saw, that you can see the flow controls. You can see they're there, and I reported on them, and all the information is there. But who's this? This is Robert, isn't it? So yeah, I don't know. Not at the minute, but we certainly, if we can get some information from customers about how they annotate them, rather than us just having a wild guess at it, that would be great. So that's what we'll be actively doing. And if Robert wants to send in a drawing or something, then that would be good. A nice example of how he annotates his flow controls. Then our first pass at doing it will probably be exactly how he wants it. So there might be an advantage there. But yeah, certainly something we considered, but we're not a little bit further down the pipeline, that one.
Thank you, Mark. A question from Scott. This might be a duplicate, actually. Are the flow controls only displayed from flow software, or are these also displayed when imported into microdrainage?
Not from microdrainage. Obviously with flow, it's our software. We have control over the format, and anything that we want to put into the file, we can, such as flow controls and storage, we can then import and display. As far as the .sws and .fws files that microdrainage produce, they don't actually hold the flow control information. They hold just the hydraulic information for the pipes and the nodes. So it's that's what we import at the minute. So MDX is not a published format, is my understanding. So
thanks, Mark. Stuart asks, in simulation settings, you have additional storage set at 20 cube per hectare. He says, I assume that this is like the MAD factor in microdrainage. Is that a default setting? Yeah. And
yes, no, exactly that.
Zero as a default.
You can set it down to zero. That's fine. It's just we keep that 20 cube per hectare as per the Wallingford procedure. So, but yeah, you can reduce that down to zero.
Thank you, Tom. Question from Scott. Re the annotations. Can the run S1 text be removed on the annotations?
I failed because I don't know. I'd need to check that out for you, Scott, because it's something that appears now. And what you can do is you can display, one thing I didn't mention is you can display this annotation on separate layers from the drainage itself. And it may be that run S1 text could potentially be on a different layer. So I need to go and check that to see whether, because that's the only way. So there's no way of actually removing it from the annotation as it stands, but it could be that if it's on its own unique layer, then you can simply freeze that layer off. But I'd need to check for you. So I take it I can answer later on, can I?
Yeah, we'll get back to you on that one.
So loud, is it? Okay, all right, good.
A question from Stuart in Flow. Is there a conduit designer?
Yes, there is. Yeah, just because of the time constraints, you can generate different conduits, and that you can build that up as a library. So you can build in swales and have those swales follow the ground levels. So yeah, or if you want to put in culverts or splayed edges, you can do all that and have those set those yourself.
Thanks, Tom. Another question from Robert. How does flow deal with model instability between storage and flow controls separated by short pipes? Does this require storage and flow controls to sit on the same manhole, similar to micro drainage?
Very good question. We follow, so we use because we use the swim engine, which solves the San Vernan equation, the 1D San Vernan equation. You're not having to put in dummy pipes, and you're not having to have the DVD damping that you would get in micro drainage. And so you are able to put flow controls on manholes. You can also, if you wanted to have those offline, you could also have them offline, but have it as an actual pipe rather than the requirement of a dummy pipe. And because the reason you get the instability is because of the diameter to length being lower than a 10:1 ratio. So,
thanks, Tom. We've got 10 questions left from a whopping 30, so thanks for your participation. So the next one's from Dom. When using underbuilding drainage, can you put a chamber outside the building before the connection to the main drainage run and include this chamber in the manhole schedule?
If that chamber was part of the PDD network, then yes, and it would be included in the manhole schedule. If it's anything to do with services under and around building drainage, then it will not appear in the main PDD schedule. So that manhole schedule is only for PDD entities. That kind of makes sense.
Thanks, Mark. A couple of questions from Robert again. Does the underbuilding domestic drainage include cover warnings for SFA 6th to 7th, or are you able to specify cover warnings?
It does. You can specify what you want the cover to be, so it will do that for you. I don't believe there's any sort of specific warnings if it breaks cover. No.
Thanks, Mark. And another question, are you able to apply concrete protection to pipes with insufficient cover from within PDS, either services or PDD?
Not currently, so be something for our roadmap.
Thank you.
He's asking all the nasty questions, isn't he, this Robert?
It's very useful to know, though, isn't it? So we can run
yeah,
things
absolutely.
in the future. Okay, another question from Siobhan. Does the private drainage module allow underbuilding, or is it the private service module required also?
Sorry, can you repeat that, Jenny?
Yep, sorry. Does the private drainage module allow underbuilding, or is the private service module required also?
That's all part and parcel of the same module. So the one that the one that we were showing there, Mark was showing, is underbuilding and round building, but it's in the services module.
Okay, great. Thanks, Barry. Question from Martin. Are the flow calculations output accepted by the water authority, such as UU and Welsh Water?
So in a couple of days, we're running a webinar for the members of the LASU group, and so we have had customers that have submitted to Severn Trent, and they've been accepted. And so yes, we haven't had any pushback from people. And
UU.
Yes,
we've had design customers submitted design to United Utilities and got approval. Yep.
Thanks very much, guys. Question from Peter. When will PDS be compatible with AutoCAD 2018?
And that's me. Well, we've got a release pretty much ready to go for hopefully for the end of this month, early next month. So by then, we've been waiting really for anything to come out of this release that may need putting into that. So end of the month, hopefully. That's it. Sorry, we lost Jenny.
Sorry, I managed to put myself on mute.
So we needed to put some money in the meter.
I've run out. A question from Chris. How would you create an IFC file?
How would you create an IFC file? You wouldn't. Currently, the IFC definitions for infrastructure and external works don't really exist, actually. And so most of the customers that we work with who work in the BIM environment tend to have focused on Navisworks as being their BIM collaboration tool of preference. So we've focused our efforts on getting the information out of PDS and into Navisworks.
Thanks, Barry. We've got a question from Robert saying, can you specify non-circular ponds that accurately calculate volumes in flow?
So are you saying, did you want to generate the pond profile in PDS and then bring that in? It's a difficult one to answer, really. It depends how you'd want to generate that.
Okay, well, I'll answer the P. Shall I answer the
PDS?
I mean,
in PDS, yes, you can create a pond of any shape, and you can export that into Flow to incorporate as part of your network analysis.
Thank you. Nearly there. Question from Stuart. Is the BIM output internal pipe / manhole diameter? Can pipe manhole wall thickness be applied somehow for accurate clash detection in Navisworks?
Currently, what we're displaying is the pipe diameter and the manhole diameter, but it's the actual size. It's not taking into account thickness of manhole or pipe currently. That is something that we are aware of a requirement for and is on our roadmap. But currently, what we're displaying for clash checking is the actual pipe diameter. So it'll be the 225 or the 1200 in the case of a manhole.
Thanks, Barry. Question from Nick. Can cover opening sizes be incorporated when producing manhole schedules?
not at the moment, so that's another one for our wish list, I think.
Taking lots of notes. Question from Matt. Are the manhole schedules live, or do they need to be deleted and rescheduled after moving manholes, etc.?
They're live, so if you've got your auto updating set, then they update as you import.
Thanks, Mark. And the last two questions, one from Nicholas. Can you add plot footings that would interact with the plot drainage that you have covered today?
He's left. Plot footings, yeah. So, well, the answer is not. Can we do it? Is something possibly we could, but it's not something that we do at the moment.
Not
I think what they're saying is, if I move a house, maybe then I want all the drainage to all.
Oh, I see.
With it. That's what I'm guessing is getting.
Yeah.
Okay, and the last one from Nick. What is the growth factor? Does that make sense?
Oh, so the growth factor is used in when looking at the greenfield runoff rates and volumes, and that is basically the IH124. So it will interpolate down the amount of the contributing area compared to the 50 hectare as per the ICP.
Thanks, Tom. Okay, so that's all the questions covered. Thank you so much for your participation.
Yeah, I mean, I think that's the plan, Jenny. Actually, just sorry to butt in, but yeah, I mean, these sort of webinar sessions are, this isn't a one-off. We're planning to do these on a fairly regular basis to try and keep the customers up to date with what we're doing in the software, and any feedback they've got in terms of things they want to see, obviously, always welcome.
Thanks so much, Barry. Mark, Tom, anything else you'd like to add?
Really, just one last thing from what Barry said there. Yeah, thanks for that feedback, and we'll take that forwards and have a look at that for inclusion potentially in the software in the future.
And yes, if anybody needs any more information on where each of those modules sit and where they lie within our group of softwares, then please feel free, send me an email, tom.fox@causeway.com.
Great, thanks so much, guys.